Hi everyone, let us discuss this example. In this example, we have a function sin t into sin phi t divided by t, and we have to find its Laplace transform. See, we have studied different techniques of finding Laplace transform. Effect of multiplication by t, effect of division by t, first shifting theorem we have studied, second shifting theorem we have studied. So all these techniques we can use to solve problems now. Okay, so what we have, I will write the given function properly first. So we have, let me write, we have, so what we have, 1 by t, I am writing in this way, sin t into sin phi t. As you can see there, 1 by t, so that means definitely we have to use effect of division by t. So what will we do? We will consider this function first. After that, we will use effect of division by t. So I am going to consider these two functions simultaneously. Consider Laplace of sin t sin phi t. Okay. So there is a product of two functions. When you have addition or when you have subtraction, you can take separate Laplace transform. But when you have multiplication or division, you cannot take them separately. So what will we do? We will use the knowledge of trigonometry and we will try to make them separate. We have the formula minus 2 sin A sin B. You remember this formula? The formula is cos A plus B minus cos A minus B. So this formula we have, this formula we can use here. But the problem is that we have only sin t into sin phi t. That minus 2 is missing here. But see, minus 2 is a constant, we can easily adjust. Let us multiply and divide by minus 2. So I am writing 1 upon minus 2 Laplace of minus 2 sin t into sin phi t. Okay. See, minus 2 is constant, so you can take inside, outside, doesn't matter. So this is equal to minus 1 by 2 Laplace of, I am going to use that formula here. What is A? A is equal to t. What is B? B is equal to phi t. So that formula says cos A plus B, that means addition of these two, which is 4t minus cos subtraction t minus phi t, it will be minus 4t. Okay, so sorry, here we have to add, right? So it will be 6t, correct? So you know that in case of sine, if there is minus sign inside, it comes outside. But in case of cos, cos absorbs that minus sign. So because of that, cos will absorb that minus sign and we will have minus 1 by 2 Laplace of cos 6t minus cos will absorb that minus sign and we will have cos 4t. So simply subtraction is there, so that means we can take separate Laplace transform. Let us see what will happen if you take separate Laplace transform. This is equal to minus 1 by 2. Okay, I am writing here. So Laplace of cos 6t. You know the formula. Laplace of cos 80 is s upon s square plus a square. So a is equal to 6. So this is s upon s square plus 6 square, which is 36, minus, right, cos 40. Its Laplace will be s upon s square plus 4 square, which is 60. So in this way we found out the Laplace of sin t into sin phi t. So this task is done. So now we have to consider an entire function. That means we have to consider that 1 by t also. Let us consider now, consider Laplace of 1 by t into sin t into sin phi t. So you know that 1 by t is there, that means definitely we have to go for effect of division by t. What we do in case of effect of division by t? Simply we take integration with limits s to infinity, you remember, okay? So limits are fixed, s to infinity, and integration of what? Integration of Laplace of neighboring function, which we have already calculated. It is minus 1 by 2 s upon s square plus 36 minus s upon s square plus 60. Okay, so we have to integrate now. So that minus 1 by 2 is constant, and when we integrate, we always take constants outside. So let me do that. So minus 1 by 2 integration s to infinity in bracket s upon s square plus 36 minus s upon s square plus 16 ds. So now the question is how to find the value of this integration. It's very simple. See, when we solve problems of Laplace transform, mainly two formulas of integration we use. First is integration of 1 by x, which is log x, you know. And the second one, that thing also I had explained in last video, that integration f dash of x upon f of x. You know, its integration is log f of x. Okay, so this formula is also very important. What we do, when the derivative of denominator is present at numerator, in that case you can use the formula and we get log of denominator. So let us think about this. What is derivative of denominator? Derivative of s square is 2s, derivative of 36 is 0. So that means derivative of denominator is 2s. Out of 2s, s is already there, simply we have to adjust 2. Same thing is true for the second term also. Derivative of denominator is 2s, only s is there, 2 is not there. So what will I do? A simple logic, that means I will multiply and divide by 2. Let us do, I am multiplying this entire term by 2, so you will have 2 here, and I am dividing by 2, that means 2 into 2 you will have 4 here. Simple adjustment we have done. So that's why this formula is applicable here, and by this formula what can I write? Log of denominator, that means log of s square plus 36 minus integration of that one will be log of s square plus 60. But see, there is no more space to write, so make a screenshot of it, then we will go further. Okay, so let us continue it here. So minus 1 by 4 is a constant. As I told you earlier, its integration will be log of denominator, that means s square plus 36 minus log of same value, same formula I am using here, log of s square plus 16 with limit s to infinity. Okay, but see, after solving the integration, what we do, we put upper limit minus we put lower limit, but here we adjust, we arrange that term properly, then after that only we put upper limit and lower limit. So here I am going to use the property of log. So you are familiar with that property, log a minus log b, which is equal to log a upon b. So this property of log I am going to use here. See what will happen, let us see, minus 1 by 4. So it will be log a upon b, first bracket upon second bracket. So s square plus 36 minus s square plus 16 with limit s to infinity. So this is equal to minus 1 by 4, right? After that, so now we can put upper limit. But when if you put upper limit here, you will have infinity at numerator, infinity at denominator. So that means indeterminate form, and L'Hospital's rule is applicable here. So by solving it, you will have 1 and log 1 is 0. So that's why I write directly 0 minus. When you put a lower limit s, you will have the same term. So log of s square plus 36 upon s square plus 60. So what will happen? Minus minus plus, and final answer will be 1 by 4 log of s square plus 36 upon s square plus 60. So this is a final answer. Make a screenshot of it, then we will stop. Thank you. Bye bye.